Okay, welcome to chapter 6, and we are just going to start with some vocabulary and some diagrams and things like that before we get too far into this. So the first section is going to be talking about perpendicular bisectors of a line segment. What that means is if you have a line segment, let's say we have segment A, B, like this, okay? A perpendicular bisector means that you're going to draw a line that is perpendicular to it and bisects it. In this case, bisects means going through the midpoint. So if we draw a line that is perpendicular, like this, the other thing that it is going to do is bisect segment AB. So that means that we have the distance from A to C equals C to B. That's just a midpoint. A bisector of a segment means you break it into two equal pieces. Okay, and so I kind of drew a diagram of that already, so that's already up here. So we have a perpendicular bisector diagram would be right here, where we have a segment. The red line is perpendicular to the black segment, and it splits that black segment in half. Perpendicular, right angle, bisector splits it in half. Okay, if we have a perpendicular bisector, so let's draw that diagram here again. Here is point A, here's our segment, here's point B. Okay, if I draw in my perpendicular bisector like this, that means that I have a right angle here, and that means that this segment and this segment are equal to each other. It also means the property that I'm talking about here is that if I put a point on the red line on the perpendicular bisector, so let's say I put a point anywhere on that perpendicular bisector, let's call that point C. That means that if I draw a line from C to B or C to A, those two segments are also going to be the same. So down here on our properties notes, it says if point C is on the perpendicular bisector, then it is the same distance from, in this case, the endpoints of the segment. Okay, so that means an example here, what we have, point C is on that red line, so we would know that AC equals BC. So if we just look at a couple of examples here, it tells us that we want to find what RS is. Well, we know that S is on the perpendicular bisector. I know it's a perpendicular bisector because it's got a right angle mark here, and it tells me those two segments are the same, which means if SP equals 6.8, that also means that RS also has to be 6.8 because they are going to be the same distance. Okay, similarly, let's see, it says we have a perpendicular bisector here. We know it's a perpendicular bisector because we have the distance from that point on the perpendicular bisector to the endpoints of the segment are both 24, which means it's perpendicular and it breaks this segment in half exactly, which means if FG is 9.5, EF also has to be 9.5. And if EF is 9.5, then EG, the whole segment, would be 9.5 plus 9.5, which is 19. Okay, so looking at just a couple more examples here. Now we have a little bit of algebra that's going with it. From the figure, BD is the perpendicular bisector, which means if it's the perpendicular bisector, that means that point D is the same distance from the endpoints of the segment. So that means that 3x plus 14 is going to be the same distance as 5x. And all that we would have to do is go ahead and solve that. I'm going to subtract 3x from both sides and I get 14 equals 2x. If I divide by 2, I get x equals 7. Then it just wants us to go back and plug those things in. So if AD is 5x, that would be 5 times 7 is 35. And CD had better be the same thing. So if I put 7 in for x, I would get 3 times 7 plus 14. 21 plus 14 is 35. Okay, so that's just a perpendicular bisector of a segment. Now, actually, what we're going to do in this chapter is start looking at what if we have a triangle and we find the perpendicular bisector of all 3 sides of that triangle. So if we look at this diagram right here, all of the blue lines are perpendicular bisectors. So if you notice, this blue line right here splits this side into 2 equal pieces. You have the 3 tick marks on there, and it would also be a right angle right there. This blue line right here, okay, breaks this side into 2 equal pieces, and it would be perpendicular. And then this blue line right here breaks this segment in half into 2 equal pieces, and it would also be perpendicular. This point in the middle where they all 3 meet, right here, you can darken that in, where they all 3 meet is called a point of concurrency. A point of concurrency just means it's where more than 2 lines meet. Okay, so in this case we have 3 lines that are all meeting at the same point. That point is called the point of concurrency. Okay, and the point of concurrency of the perpendicular bisectors is called the circumcenter. Okay, and one thing about the circumcenter that we need to make sure that we know, what property does that circumcenter have? The circumcenter is equidistant to the vertices of the triangle. Okay, so going back up to our diagram, let's see, I haven't used yellow yet. If I use yellow here, that means that this point, the black point I have in the middle, if I measured from that point out to this, or out to here, or out to here, all of the yellow lines would all be the same measure. That's what it means when it says the circumcenter is equidistant from the vertices. Okay, so what I'm going to have you guys do is just do a little exploration with the circumcenter. And there is a link in Schoology where it's going to take you to a GeoGebra file where it's going to have you make the circumcenter in a triangle. And so make sure you follow these directions. So when you open the link, there's going to be 3 or 4 steps that it wants you to do. Make sure you do those steps and you do them in order. However, it does have a toolbar across the top. A couple of important things before you get frustrated with the toolbar. One of them is if you ever want to move a point or anything in that file, you have to have this right here clicked, the arrow button. If you do not have the arrow button clicked, it's going to make some random things in there that you do not want. The only other 2 buttons that you're really going to have to use on this activity is this one, what I have circled in blue. That is where you're going to mark your circumcenter. That's where you're going to have all 3 of your points or all 3 of your lines are going to meet at a point, and that'll be in the directions. And then the other one is this one right here. That's where you're going to find how to do a perpendicular bisector. When you click this link right here, or click that button on GeoGebra, it brings down a drop-down menu. Make sure that when you are finding the perpendicular bisector, you click on that tool, and then make sure you click on perpendicular bisector. Otherwise, all the other things are going to come up and it gets a little bit confusing. If you finish all the way through the activity, it does have you make a circle with a center at the circumcenter and then through one of the vertices, so you can kind of mess with that just a little bit. But other than that, the key that I find very frustrating with the program is you have to have, if you're going to move the corners of the triangle or anything to kind of see what your circumcenter does, you have to have that arrow clicked, otherwise it won't work. So there's some steps in the link in Schoology that kind of tells you what to do. And then if you want to come back to this, if you have time today, otherwise we will go through the rest of the slides together tomorrow.